Hi everyone. In this episode, I just want to discuss a small shortcut for division of potential differences across capacitors in series, two condensers in series, and division of currents across two resistors in parallel combination. First, let me show you what I am doing. We have a circuit before you, which is a 6 mF and a 3 mF condenser connected in series with a 120 volt source. You are asked to calculate the P.D.s across the first and the second condensers. We know the relation that governs the charge, capacity and potential difference across the condensers is given by Q is equal to V. We know that charge is same across all the condensers in series combination. Therefore, Q is equal to CV. In this, Q becomes constant. Therefore, C and V are inversely related. Therefore, V1 is to V2 is equal 1 by C1 is to 1 by C2. In other words, the potential differences get shared in the inverse ratio of capacitances. So I am first providing the steps, then I will explain the shortcut. Therefore V1 is equal to Vc2 by C1 plus C2. That means 120 into 3 by 6 plus 3, which is equal to 40 volts. V2 is equal Vc1 by C1 plus C2. 120 into 6 by 6 plus 3, which is equal to 80 volts. In fact, V2 you need not calculate because in series combination, sum of the P.D.s across the condensers is equal to total P.D. So because the first one you got as 40, automatically the second P.D. must be 80. So that the total becomes 120. In other words, the simple shortcut you can use in the inverse ratio when two quantities are to be inversely shared. The first quantity is equal to total into second by sum. The second quantity is equal to total into first by sum. This is the simple logic when two quantities are to be shared in the inverse ratio. So this is how if more than two are given, naturally we will calculate in the conventional method. V1 is to V2 is to V3 is equal 1 by C1 is to 1 by C2 is to 1 by C3, so on. So that's how that is the usual procedure for more than two, but usually in competitive exams, because time is the factor, with two condensers are given in series and you can use the shortcut. Now let's go to resistors. Let us imagine a 6 ohm and 12 ohm resistors are connected in parallel and with a 3 amperes current flowing through the combination as shown in the circuit in front of you. You are asked to calculate the currents flowing through the first and the second resistor, 6 ohms and 12 ohms. You know from Ohm's law, V is equal to Ri. You know from parallel combination, P.D. remains same. So R and I are inversely related because Ri is equal constant. I1 is to I2 is equal 1 by R1 is to 1 by R2. Let's apply the same shortcut. I1 is equal to I R2 by R1 plus R2, which is equal to 3 into 12 by 6 plus 12, which is equal to 2 amperes. Similarly, I2 is equal to I R1 by R1 plus R2, which is equal to 3 into 6 by 6 plus 12, which is equal to 1 ampere. As usual, in the earlier method, you need not calculate I2 because once I1 is known, automatically I1 plus I2 flow back to the circuit as 3 amperes. Because I1 is 2 amperes, automatically I2 stands to be 1 ampere. So the golden shortcut and the simple shortcut in all such cases of sharing of a given quantity in the inverse ratio among two units is first quantity is equal total into second by sum. Second quantity is equal total into first by sum. So using this shortcut, we can always share a given quantity among two units in the inverse ratio, and this shortcut is applicable anywhere and at so many other places in physics where we got to share a given parameter, given quantity among two different units. Right then, good day, thank you.